Hey, GED students. So this video is for Brittany. So Brittany's part of the GED support group that I admin, one of the admins. It's called GED We Study and Help Each Other. It's a great resource if you don't belong to it. 16,000 GED students and teachers from all over the world helping each other out. Brittany, speaking of, posted that she was really struggling with the GED style slope application problem worksheet that I have up on the crash course. So this one is from the slope review lesson. So it's meant to be completed after you've already done all 4 of the other slope lessons on the crash course, because these are the very trickiest examples of what you might see on the GED, where we have slope from all different types of information in the same problem. It is challenging. So it's no wonder Brittany was like, wow, this is hard. Let's take a look, okay? Number 1, it says the equation y equals 255x represents the gross sales Y that Bling Bikes makes by selling X bicycles. Which data display shows a company that makes less money per bicycle than Bling Bikes? Oh my goodness, that's a lot of information. But let's hone in on what they're asking us to do or to find. It says which data display. So here we have 4 different data displays, a couple of graphs and a couple of tables. So which one of those shows a company that makes less money per bicycle? There's the key word right there. We're looking for something that makes less money per bicycle. Now, as soon as I saw that phrase, money per bicycle, I was super excited, because that right there was some language that signaled me that even though this looks like a complex problem, we are just finding unit rates. We're comparing, in this case, unit rates. A unit rate is when you're looking how much for one thing. So when I say money per bicycle, I'm talking about how much money per one bicycle. Take a look at the equation first of all. You might not recognize this as a slope problem, but unit rate is a kind of slope, right? Slope is the rate of change. So in this case, see how it's y equals 255 times x? Well, x is, the bicycles. So what they're saying here is that I make $255 each time I sell another bicycle. This is a case of $255 per bike. Just look for the number that's multiplying with x, that's shoved up against x, and that's your unit rate, your slope, your rate of change. Okay, so that guy is making $255 per bike. Now, it's really easy on the tables. So I'm going to go to the tables next to see how much they're making per bike. Okay, so let's take a look at this table for pedaling. You can see that in the first column, I have number of bikes, and in the second column, I have the gross, the money that they're making. So if I want to find the money per bike for this company, what I need to do is do exactly what this phrase says. It tells me what math to do in the phrase, guys. It says take a dollar amount. Okay, well, I'll start with this line here. The dollar amount, the money they're making, is $12.40. And per it, or divide it by the number of bikes. Well, how many bikes did I sell to make $1,240? That's 4. And let's figure that out. 1,240 divided by 4, it looks like I'm making $310 per bike with pedaling. Okay, that's definitely not less money than Bling. Bling made $255 per bike. Pedaling makes more. All right, let's look at Wonder Wheels. Again, it really doesn't matter which line you do, okay? That's the point here. We have a constant rate of change, like we're making the same amount per bike, okay? So let's go ahead and look at this one. We are gonna make, again, I'm looking for money per bike. The money here is how much? Well, it looks like in the gross column, I see I'm making 4,125. And if you don't know the word gross, it just means the total money, like before you take out any expenses or taxes or anything like that. So $4,125, and we're going to per it. Per literally means divide. In fact, sometimes we even abbreviate the word per with a slash, just like we use that slash, that divide, for divide. So $4,125 per 15 bikes. Let's divide that out to find the price for just one bike. 4,125 divided by 15, and we see that's $275 per bike. Well, that's a little closer to that 255, but we're still not less. It's not Wonder Wheels either. And see how even if you are just really scared of graphs, a lot of students are scared of the graphs. They're not that hard. We'll look at them in a second. But even if you're really scared of the graphs, I could have already ruled out these two. And now I have a 50-50 shot at least of guessing which one of these might make less per bike than bling bikes. But I just want to show you this is way easier than it looks. Just like on the table where we only needed to look at one of the lines, if we're on a graph, we only have to look at one of the points. So I don't know, let's just look at how much we make. This says number of bicycles sold, so that's 12 bikes. And let's go up to our graph here. When we sell 12 bikes, we make about $2,500. Now you can't tell exactly on a graph, that's why I say about, but close enough that you'll be able to tell. If I want to figure out the money per bicycle, again, I'm going to start with the money. So that is making, let's see, gross sales. And oh, that's supposed to say gross sales. It says grass sales. You guys, apparently I'm selling grass. I don't sell grass. I'm reformed. Okay, gross. So, dear Lord. Oh, it's a day already, you guys. Okay, so gross sales in dollars. So how much am I making here? I'm making about $2,500. And I'm going to per that. I'm going to divide that by the number of bicycles sold in that case. In this case, it's 12 bicycles. Okay, so let's do that. $2,500 divided by 12 bicycles to figure out how much I'm making on just one bicycle. And look at this. This is super exciting. $208. And, you know, we see this 0.333, but, you know, I approximated. So no wonder I got an ugly number. But I'm making about $208 per bike. That's looking good. That looks like it's less money per bike than bling bikes, which made $255. Now, that being said, I will check the last graph just to be sure I'm right and so that you guys get a little more practice. So once again, it really doesn't matter where on the graph you look. Like you could look at 20, you could look at 30, you can look at 40. But I like to go to the highest number that I have because it makes your estimates more accurate. When you deal with lower numbers, it's way easier to get an inaccurate estimate. So look, when I sell 40 bicycles, I'm making about $12,000. Oh, look, it is gross sales. This time I'm not selling grass, apparently. Well, it wasn't me selling grass, you guys. It was Bruce's. Very suspicious. So I'm looking for money per bicycle. So the money here is $12,000. Woo, speedies. And I'm going to per that, divide that by the number of bicycles, 40. And I get 12,000 divided by 40. Oh, I'm going to get 300. Yeah, this one's definitely more expensive. It's 300 per bike. We were right. Bruce's bicycle makes less money per bike, only $208, than bling bikes made, which was $255. So this problem right here is such good practice because we've found slope 4 ways in one problem. Okay, so we just practiced all 4 slope lessons at once. First of all, we have this word problem here. It's a real life scenario with this money per bicycle. We had to recognize that when they said money per bicycle, that unit rate is a rate of change. It is slope. They're the same things. That's why we learned so much about slope, because there are these rates that show up in real life. Okay, money per bicycle, miles per hour, dollars per hour, all these rates that we have in the real world. Well, those are slopes. That's how fast something is changing. We saw it in a word problem. Then we see it in equation. They gave us the equation here. So we had to recognize that that number multiplying with X is slope. It's how fast we're changing based on what you make X to be. And then we had a couple of graphs. So we had to be able to find slope off of some graphs, and then a couple of tables, slope off some tables, all in a unit rate context. So very challenging example here. So I'm super glad that Brittany was struggling with this one so that we could tackle it together. All right, this is expert level slope problem. Let's go see if there's any other tricky concepts we can look at together here. The next few examples on this page are the same kind. So you guys should practice 2, 3, and 4 to see how you can do. So I'm going to flip on to number 5. Let's go ahead and take a look at that. It says Jose owns a food truck. He is analyzing expenses and income to increase profit. The expenses include renting the 1,100 square foot lot, which he parks his truck on, for $2,500 per month. What is the rental cost in dollars per square foot that Jose pays for the lot? Once again, I'm super excited, guys, because hone in on that question with me. Look at that question. It says, what is the rental cost in dollars per square foot? I don't have to remember anything about slope. I don't have to remember any formulas. They tell me exactly what to do. They're telling me to find the rental cost, and then they tell me how to find the rental cost. They say in dollars per square foot. There's that unit rate language again. They're telling me to take the dollars and per it, divide it by the square feet in order to figure out the unit rate, the dollars per square foot. Okay, let's do it. So how many dollars does he pay for this lot? Let's see, parks his truck. Oh, for $2,500 per month. So we'll start with the dollars, 2,500. And we're going to per it. We're going to divide it by the square feet. And this problem's real nice because they actually gave us the square feet. They were super sweet. 1,100 square feet. So let's divide it by 1,100 square feet. Once again, I'm going to pick up my calculator. You would always have a calculator when you're doing slope problems, word problems on the GED. And I get, looks like 2.272727. But remember, this is dollars per square feet. So I'm talking money. So money is going to end after 2 decimal places, right? The smallest coin we have is a penny. So that's really about $2.27 per square foot. Now you are equipped to try number 6, but take a look at number 7. Number 7 got a little trickier. Same wording, but they gave us different information. Watch out for that. So Mark owns a photography stand at the zoo. He is analyzing expenses and income to increase profit. The expenses include renting the 12-foot by 15-foot space at the zoo for $1,500 a month. What is the rental cost in dollars per square foot that Mark pays for his space at the zoo? Now you might be saying, Kate, we just did this problem. Like, it looks identical to me. Well, I kind of agree. Let's take a look. First of all, I am looking for the same thing. It definitely says, what is the rental cost? And it tells us exactly how to find rental cost in dollars per square foot. They want the unit rental cost, not the total. They want dollars per square foot again. I forgot to finish writing it on the last one. Dollars per square foot. And we know how to find that. We start with the dollars. Dollars, that's 1,500. And we per it, per, divide by. But careful, this asks us to divide by the square foot. Square foot. This is why this is considered an advanced level problem, because now they're pulling geometry into this because they didn't tell us the square foot. Go ahead and look at the problem. It says the expenses include renting the 12-foot by 15-foot space at the zoo. They tell us the dimensions of the space. So it's a rectangle because they didn't state otherwise, give us any clues that it would be otherwise. We see 12 feet by 15 feet, but what we don't know is the square footage, the number of squares to cover that rectangle. That's area. It's like a hidden area problem. So we're going to have to find this area, this square footage, before we can find the dollars per square foot. So how do you find area of a rectangle? You can take a look at your formula sheet. It'll tell you area of a rectangle is equal to length times width. But a lot of students remember this one without a formula sheet because you just multiply the 2 dimensions. So let's do that. Length times width, 12 times 15 gives us 180. Now that is in square feet. That's 180 square feet. Now I have the information I need to divide. See how this one was trickier. So 1,500 divided by 180 square feet gives me, oh, I must have typed something wrong. I'm $83 per square foot. Kate, you have gone awry. Let me try one more time. 1,500 divided by 180. That makes more sense. 8.333. and so on and so forth. Once again, I'm talking dollars per square foot. This is money. Money in the US only goes to 2 decimal places because pennies are our smallest coins. And so that's about 8.33 per square foot. All right, let's take a look at another example. Not so much the word problem, but again, we have a slope comparison problem. So we're going to have to understand slope in a lot of different ways. So let's go ahead and take a look. It says, consider the slopes of the three functions below. Order them from the smallest slope to the largest. And then we see something a little different going on here than the last problems we saw. So the last problems we saw, we were looking at money we made per item, like how much we sold each item for. So that's a really straightforward problem. We could just divide because you just make the same amount every item. If you sell 0 items, you make $0. It's a really simple, straightforward problem. These are a little more complex. We don't necessarily know here if 0, 0, so when you sell nothing, you make nothing, is on any of these lines here. And so I'm actually going to resort to my more typical slope methods where I divide, yes, but I divide the change in y, as we call it, sometimes we also call it rise, over the change in x, run. So let me just take note of those things. So slope, we learned in our intro to slope video, is the same as rise over run, the change in y, how much my line is going up, over the change in x, the run, how much my line is going left or right. In order to do that, I don't just need 1 point, I need 2, because I'm looking for change. So now a lot of students look at this graph, they say, what 2 points should I use? Remember, it does not matter. Again, a line has constant slope. I don't care where you start and where you end. You just need to start on the line and end on the line. Okay, now we can pick wisely in that we can pick points that are easy to see what the numbers are. So like, for example, I could start right here. It's really easy to see where I'm at. I'm right there, at 0, 2, okay? And now I want to count. I want to go from that point on the line to another point on the line, counting how much I have to rise, how much I have to go up, and how much I have to run, how much I have to go over. So let's see if there's another point that's real easy to see. Yeah, I think this one is really easy for me to see. It's right there between 2 and 4, so it's at 3. So I think I can see this. So I'm starting at 2 and I'm going up to 4. So I'm going 1, 2, up. And then I'm starting at 0 and I'm going over to 3, 1, 2, 3. So I'm going 3 over. So if I'm going to do my rise over my run, I go 2 over 3. That's the slope of this line. Again, if you need a review of finding slope off of a graph, go back to the intro to slope lesson. That's the first thing we learn. Okay, now let's look at the next one. Function B. Again, I just want the slope. This thing that they gave me, it might look confusing to you, but it's the equation of a line. Now, first thing that confuses students is this f of x notation, this right here. This doesn't say f times x. If I wanted to write f times x, I would write it like this. No need for parentheses when it's just letters. That says f of x. And it's just a short way of saying f is a function of x, but that confuses students. So just know this. It means the same as y. If it's freaking you out, cross it off. F of x means the same as y. It's like y's formal name, okay? I don't know what your name is. Let's pretend it's John Smith. I could call you John. That's like saying Y, informal. Or I could call you Mr. Smith. And that's the more formal way to address you, like F of X. But I'm still talking to the same person. Okay, so Y is F of X. Same thing. So I have this y equals -1/2 x plus 7. Again, I'm trying to find slope, but this time I don't have a graph. This time I have the equation of a line. Hit up your GED formula sheet if you don't know this, but we have what's known as the slope-intercept equation of a line on the formula sheet. Looks like this. It says y equals mx plus b. Now that's interesting. Y equals mx plus b is weird. It's full of a lot of letters, but the important thing you need to understand is what the m means and what the b means. Mathematicians, we're lovely people, but we're not always the most creative people. This equation has a name for a reason. We call it the slope-intercept form of a line, and it says that right on your formula sheet. Slope-intercept, because it tells us two things. It tells us the slope That's the M. That's what M is for. Yeah, I don't know. Slope, M, whatever. And the B is the y-intercept, where my line crosses the y-axis. So there's only one thing I care about in this problem. I'm supposed to be ordering these functions from smallest slope to largest slope. So all I care about is the slope, and the slope is the m, the number that's multiplying with x. So let's go straight to that in my equation. What number is multiplying with x? It's -1/2. So the slope of this guy is -1/2. Cool, looking good, looking good. So I have the slope of this is 2/3. The slope of this is -1/2. Notice how I use the letter. It's mathematicians use M to mean slope. We're too lazy to spell the word slope. We use the letter M. Okay, and now I need to find the slope of the last function. Now, once again, they gave it to me in a different form. What jerks. You're like, it's a table. And Kate, you didn't even have a lesson on finding slope from a table. No, but I had a lesson on finding slope from the thing that's on this table. Look at what's on this table. These are x values paired with y values. Guys, these are points. This is the 0.34. This is the 0.50. This is the 0.74. I have to find slope this time given points. First one, I was finding slope off of a graph. That's one lesson. Second one, finding slope from an equation. That's another lesson. This third one now, finding slope from points. You can see why this is such a complex problem. That's a whole nother lesson. When you're finding slope from points, the easiest way to go is to use the formula. There is a slope formula on your GED sheet. Slope formula says to find slope, you do the change in y's. Like I said, you subtract two y values from two different points over the change in x's. It's just like rise over run. It's just a mathematical way of saying it, okay? The change in x's is how much I'm running. Now you might say, well, what is all this y2, y1, x2, x1? Basically, I need you to just choose one of these points to be 0.2, and it really doesn't matter which one, and one to be 0.1. So I'll call this one 0.1, and I'll call this one 0.2. So now if I want to plug into this formula, y2 is the y value from the second point. So here's 0.2, here's the y value, 12. And from that, I'm supposed to subtract y1, the y value from the first point. Okay, so here's my 0.1, I called it, and this one's 8. And again, if you're asking yourself, which one's 0.1 and which one's 0.2, it really doesn't matter. Just stay consistent. You'll get the same slope. If there's any theme to this video, it's I don't care what points you choose, you'll get the same slope. That's the point of slope. And now over that, I need the change of x's. So I'll start with the x value from 0.2. So I called this 0.2. So there's the x value, 11. And from that, I'm going to subtract the x value. That's what x1 means. The x value from 0.1. So the x value from 0.1 is 9. And now you can type this whole thing into your calculator if you want, like the entire expression. But this one's relatively easy to simplify by hand. So I'm going to do it. Remember to deal with groupings first. So the top of a fraction is a group, 12 minus 8 is 4. And bottom of a fraction is also a group, 11 minus 9 is 2. And then that number divides perfectly. I don't have to leave it as a fraction because 4 divides by 2. 4 divided by 2 is 2. Okay, so the slope of the graph is 2/3. The slope of the line is -1/2. And the slope from this table here is 2. And I'm supposed to order the slopes from smallest to largest. Okay, smallest number is definitely the negative here. So function B with my negative slope is the smallest. Next two I have left, I have 2/3 or I have 2. This is a proper fraction here. 2/3, it's something less than 1. So it's definitely going to come next. And then 2 is the largest. So answer here is B, A, C. Wipe your brow. You're doing hard stuff. Okay, this, like I said, this is the tippity top of slope. We are in challenge mode. It will take practice. There's no way on earth you just go watch a video once, watch Kate do it, and then be able to go duplicate this on your test. I want you to imagine, and I say this all the time, you guys have probably heard me say this, but I want you to imagine that you just sit in a car one time, watch your mom drive, and then you decide, okay, I'm going to pull off on the highway now and drive. That's not how driving works, right? You might watch someone else do it once or twice, but you're not highway ready until you Practice, practice, practice. And a lot of times you practice each skill individually before you put them all together before you go on the highway, right? First, we practice changing lanes. Then we practice looking over our shoulder. Well, hopefully you're doing that at the same time as you change lanes. Braking, entering and exiting, merging. There's all these skills that we have to put together in order to get on the freeway. This is the same way. This is the freeway of slope. Okay. Not every slope problem you see on the GED is going to be this complex, but this is the challenge mode. So you learn how to do each one of these slope skills individually, then you put them all together for these more complex skills. Practice. Please go practice. Go hit up the crash course, try this very worksheet and practice it yourself. And then you'll be prepared when you hit the freeway on test day. You won't be losing your mind white knuckle driving. If you have any questions about this or any other GED math topic, be sure to drop it in the comments. I'll do my best to answer it. I just want to thank everyone who supports Light and Salt Learning. I am so grateful to all of you. So to my patrons who support me every month with a $3, $9, or $15 pledge, just thank you from the bottom of my heart. And for those of you who one-off gave me a gift of a cup of coffee, some of you many cups of coffee, I so appreciate you. Thank you for keeping Light and Salt Learning alive. It's because of you that I can do what I do. To my students, happy learning, and to my teachers, happy teaching.